Good day, everyone. I will just share my screen now. So, regarding integrity management, you know that for all companies, for all oil and gas industry, there is integrity management carried out in different ways. So, for BP, I would like to say that for BP, integrity management starts even from projecting a facility till exporting product, oil or gas to final point. So today's session will cover integrity management starting from offshore platforms till export pipelines, and including Sangachal terminal. When we say integrity, in our understanding, what does it mean in reality, integrity management? Why do we need, as company, such type of process or like team within the company? Integrity management, in short, it means that keeping hydrocarbon inside the pipe, like during all protections, all monitorings, controls to keep hydrocarbon in system. And integrity management is a continuous assessment process applied throughout design, construction, operations, maintenance, and decommissioning to assure that wells, facilities, and structures are managed safely. And integrity management from BP point of view is delivered by the controlled application of major risk, process safety, and engineering management, combined with the adoption of internationally recognized industry standards, and BP developed know-how process. Applying systematic integrity management processes reduce the possibility of release of hydrocarbons and chemicals to the atmosphere or ground, and avoids the consequential serious harm to the workforce, the public, the environment, and BP assets. This enables BP to benefit from reduced risk to integrity and HSE, health, safety, security, and environment. It's acronym for this definition, to increase the life cycle values of its asset and to improve engineering standardization and productivity. But in short, integrity management is to keep hydrocarbon inside the pipe. How integrity management is designed within BP? We have operating management system, which covers 4P system, like people, performance, process, plant. And each system have its own subsystem. People is organization and leadership, performance is results and privilege to operate, process is risk and procedures, plant is optimization and assets. And one branch of this operating management system is integrity management. Integrity management covers what and who, what is the process, what is the integrity of facility, and who is responsible to do this, responsible to regulate this integrity on facilities. And integrity management splits to different subsystems. You can see here, and definitions you can see here, integrity management systems under operating management system. It's structural integrity management, subsea, pipeline, wells, civils, facilities integrity management systems. During today's awareness session, to make more simpler, to make more understandable for us, for everyone, I will cover the highlighted ones: structural, pipeline, civil, and facilities. So let's start from facility integrity management system. Is an operational system and therefore only applies to facility post handover from projects to operations. So this system is not applicable during projects, like projects covers its own integrity management. But when like startup is completed, like done, when there is hydrocarbon moves inside the piping, facility integrity management system taking control of this equipment. And for facility integrity management system covers pressure systems, rotating equipment, lifting equipment, instrument control, fire and gas, electrical and utility systems, key to safe operation, emergency response system, overpressure protective systems, which have been covered during previous sessions, and temporary portable equipment. Pressure systems, in our case, like for us, it's piping, process piping, hard and flexible, valves, pressure vessels, heat exchangers, boilers, and heaters. This pressure systems part will be deeply introduced to you during our one of the next sessions, because it's a very big topic. We cannot just skip within this just a small table. So closed drains, atmospheric vents, blow down flare systems, and storage tanks. So rotating equipment, it's pumps and compressor turbines, lifting equipment, cranes, blocks, lifting hoist, and other lifting devices, instrument control, control systems, emergency shutdown systems, HIPS relief and blow down systems, and safety instrumented systems, fire and gas ignition prevention systems, fire and gas detection, fire and blast protection and suppression systems, electrical and utility system key to safe operation. It's class division. Class 1 division 1 is like when hydrocarbon is contacting with electrical equipment. Interruptible power supplies, emergency lighting systems, navigational aids, high and low voltage motors and switchgear module, pressurization, and HVAC. Emergency response system, emergency response equipment, evacuation and escape facilities, lifeboats and rafts, firefighting equipment and systems, and self-contained breathing apparatus, personal protective equipment, emergency communication systems, collision avoidance system, temporary refuge, like rescue and recovery facilities. Our pressure protective system is relief systems, PSV, bursting disk, and so on. Temporary portable equipment, generators, compressors, pressure systems equipment, pressurized hoses, and electrical tools. So within facility integrity management system, equipment is divided to safety critical and non-safety critical. Sorry, while my computer is stuck, I will continue. Facility integrity management system is split to safety critical equipment and non-safety critical, is depending what's the system, what's the for purposes it's installed. And Can you hear me now?
Yes.
So while I'm in trouble with computer, like I will talk about safety critical equipment covered under facility integrity management system. Is a collision avoidance system, as I mentioned. It's to detect passing or drifting vessels on a potential collision course with the installation and communicate an early warning of potential corrosion risk to the installation and vessels. Process containment integrity. The goal is to provide and maintenance a safe containment during normal operation and range of abnormal operating condition within the design envelope. So the integrity of facilities assets is maintained by a risk-based approach, taking into account the consequences of a loss or containment or loss of a safety function and the likelihood of credible deterioration. Credible damage mechanisms like it will be like another session. So is also initially determined by the risk assessment and confirmed during inspections, in service inspection, and inspection plans should allow for unpredicted mechanisms as far as practicable. So this is process containment integrity. So another one is flexible hoses. All hoses are categorized, which reflects different purposes, examination criteria.
I'm sorry, Manyar Khanum, we do not see the presentation now.
Yes, I'm in trouble with my computer. I joined from my phone, and while I will share. I will restart my computer. So identified and color-coded in accordance with BP provided prepared document, like it's called AGT hose management strategy. Cranes and lifting systems. Lifting procedures also is a part of provided BP document, describes requirement to provide a safe means to lift and transfer loads and from loads to and from supply vessels around different locations, the platform and safety transfer personnel of the installation. So lifting equipment and lifting operations are also to be managed in accordance to all provided approved procedures. So rotating machinery integrity. Rotating equipment is identified as safety critical to ensure that hazardous situation in the form of project or a source of ignition or a loss of hydrocarbon containment does not arise due to a failure of rotating machinery integrity. Rotating equipment includes gas turbines and other large combustion engines operating in area classified as hazardous and non-hazardous, and compressors, pumps, and other rotating equipment operating in a hydrocarbon service and are located in areas classified as hazardous. This is about rotating equipment integrity. Module pressurization or HVAC to provide a reliable, secure, and effective means of ventilation and overpressure to enclosed areas in order to prevent the transport of potential hazardous gas and or smoke to between ventilated areas. Additionally, to provide a reliable, secure, and effective means of isolating ventilation systems in order to prevent the ingress of hazardous material when the systems are shut down. So, process shutdown systems. This is another critical equipment for facility integrity management systems to provide a detection and response function that is capable of taking rapid executive action to bring the facility to the appropriate shutdown condition to reduce the potential for escalation of major accident hazard. To provide a command support function to the facility and be capable of surviving hazards, including fire and explosion. Within the scope area, all components of process shutdown system, including signals from field devices, cabling cabinets, and logic panel hardware up to the output devices like valves, electrical tree. So relief systems we have much covered during our sessions to maintain the integrity of the pressure envelope and also to provide facilities to minimize the likelihood of catastrophic failure of pressurized equipment due to overpressure by controlled discharge in order to reduce the potential for escalation of a major accident hazard. This covers all pressure protection equipment, pressure safety valves, and bursting discs. Pressure protection devices located in the section of process plant, which are positively isolated, depressurized, and drained are excluded from the performance standard, which I'm talking about during outage period. So this was relief systems, ignition prevention, another critical equipment for FIMS to prevent major accident events arising from explosion and from fire scenarios by eliminating potential sources of ignition, electrical and mechanical equipment located in designated hazardous areas that have been identified under standard regulations as a potential source of ignition or those required to operate following hydrocarbon gas release in the area. Earthing and bonding provisions, frame and spark arresters are also addressed this scheme. So third-party transportable and temporary equipment. So this includes electrical equipment, mechanical equipment, portable lifting equipment, temporary stores, and offices under this subject. Open and closed hazardous drains, to provide adequate facilities for the safe containment and disposal of all hazardous liquids, including hydrocarbons, including released and to rapidly remove deluge fire water in order to prevent the spread of pool fires. Open hazardous drains covers all collection and header pipework, the bands surrounding plant containing hazardous fluids through to the open drain occasion. Closed hazardous drains covers all collection and header pipework. Open hazardous drains are fluids entering the system as a result of loss containment. And open drain systems have no direct connection with the process system. Passive fire protection, in our case, we are just calling PFP. The goal of passive fire protection is to mitigate the effects of a fire, maintaining the integrity of critical structural components and of equipment containing hydrocarbons and preventing their failure for a defined time as a result of high temperature caused by incident radiation or in certain cases jet fire impingement. Periodic inspection for damage and deterioration should ensure the continuance of adequate protection. Temporary refuge integrity to provide a temporary refuge integrity which protects personnel from the effects of major hazardous events for the defined endurance time, wills, and attempt to control the incident, and if necessary to organize an evacuation or abandonment of the installation. Occupied areas, particularly the temporary refuge, the other accommodation areas and control rooms have a key role in the personal safety. A specific register of external doors, of fire dampers, and supply plans supply funds in the accommodation module is kept by each asset, embedded engineering and maintenance teams and recorded in our documents. So basic maintenance check of doors, door seals, dampers, and fans are conducted in accordance with BP best practice to confirm integrity and operational availability. So while I'm moving to another one, I will try to share again my screen. So, like fixed fire water protection to provide control and mitigation measures to actively reduce the effects of fires resulting from major accident hazards. Additionally, to prevent escalation, protect structures and plant and provide protection to those systems that are essential to the preservation of life for their duration of their function under emergency conditions. Particular requirements are to ensure fire water is available at all times, including periods of planned and unplanned maintenance, in the required quantity to comply with the requirements of the fire water system calculations, to provide fire water to the deluge system, HELDEC foam monitors, hydrant stations and hose reels, to provide foam injection to the deluge system, to provide water mist system to machinery enclosures, to provide effective fire protection to galley. Internal communication system is one of the most important facility integrity management systems is to provide reliable, secure, and effective systems for alerting personnel to the existence of an emergency, signal assembly, master stations, or to prepare for evacuation. Additionally, to provide a means for those managing an emergency to broadcast messages to all personnel on board, to warn of hazards, issue instructions, and inform of incident status. Within this safety critical element, all field devices include speakers, beacons, manual alarm, supports cabling, cable racking, junction boxes, local central control panels, and independent interruptible power supplies, it's UPS, associated with the system. Emergency lifting to provide sufficient illumination for managing any incident and escape following loss of external power supply. And external communication systems to provide reliable, direct, secure, essential and effective facilities for emergency external communication with other fixed or mobile installations or in the offshore installation, marine vessels, and neighboring shore-based facilities. Additionally, to ensure that prior to, during, and post-abandonment, the communications required for the emergency response control personnel mastering platform evacuation, and with all external parties identified in the emergency plan are available. So lifeboats, maybe you are familiar with all platforms like in Caspian Sea, like in all like platforms, there is lifeboats. This is just like evacuation of personnel, and this is like called like a secondary master point in our case. First is just safest place within platform, and lifeboats is second, and integrity of lifeboats, like they're working always, they are in good condition, chains. Maybe you remember in 2016 when in soccer platform was fire, and during poor integrity of lifeboats, there was a very big unfortunate case, unfortunate incident with death people, with big this number of people. So and for us, for all oil and gas companies, lifeboat integrity is covered under facility integrity management, like lifeboats as a primary means of evacuation from the installation in an emergency. It's requirement that lifeboats and their divers remain able to perform their function at all times when process plant is operating, except for essential maintenance or testing. Emergency power supplies, to provide reliable and secure power supplies to all essential equipment during an emergency situation. This will establish essential command, control, and communication facilities for platform management in order to enable an effective and safe emergency response. The emergency power is to be a functional condition as available to provide power to essential users on loss of main platform power at all times, unless alternative arrangements are in place as agreed with our high-level management. So rescue and recovery facilities, to provide a rescue and recovery provision for persons who have to evacuate or escape from the installation, or who requires rescue near the installation from reasonably foreseeable events. Fire and gas system. The goal is to continuously monitor designated areas of the installation, and upon a detection of a fire or an accumulation of flammable gas or smoke, to initiate alarms and provide output signals to field devices which initiate a rapid and appropriate response in accordance with the fire and gas causes and effect charts. And safety instrumented systems, you are already a little bit familiar with this. It's one of the main safety critical systems within facility management, facility integrity management. The goal is to detect and respond to a predetermined trip criteria, and to initiate various levels of manual automatic isolation and shutdown of process plant equipment and the wells in a safe and orderly manner. And risers and RVs, it's also part of FIMS, to prevent, reduce the loss of inventory released in the event of major accident hazard. This is achieved by providing suitable and reliable barriers to isolate the incoming fluid, the pipeline inventories, and to associate the topsides process and utilities in defined areas in order to minimize potential for incident escalation. blow down, vent, and flare systems to provide facilities for rapid removal of hydrocarbon inventory from isolated sections of the facilities to a safe disposal point to reduce the potential for escalation of a major accident hazard. That's all for FIMS. Another was like one of the SPE operating management systems, integrity management system is pipeline integrity management system. Maybe you are familiar for us, like pipelines, pipeline definition is when from terminal we are sending hydrocarbon to export, like to final direction, and the pipelines is meant materials, equipment which we send hydrocarbon from offshore platforms to Sangachal terminal. Pipeline, from equipment which is used between offshore platforms and Sangachal is called offshore pipelines, and onshore called like from Sangachal to export, like let's say as an example, Baku Tbilisi Ceyhan to Ceyhan station, we are using onshore pipeline system. Pipeline systems onshore and offshore provide a safe and efficient means of transporting a wide range of commodities such as oil, gas, petroleum products, and chemicals. They are found in all parts of BP. Operations from upstream production flow lines to export pipelines in all segments, including downstream delivery of raw materials, chemicals, and refined products. And FIMS is effective pipeline integrity management, which is our essential target, that integrity of pipeline improves operational performance through enhanced health, safety, security, and environmental performance, and business performance through increased availability and productivity. So when we say pipeline, for us always is important that this is very huge equipment, and of how we control internals. Like it's not just equipment, just we can take offline and just inspect or do our monitoring to see what's the condition. Pipelines are the kilometers of piping connected together within sections, and we cannot just switch off just small section and say that I am monitoring this part. And for maybe you are already informed about peaks. It's like integrity tool, like which are using within the pipeline equipment, either for just maintenance cases, just internal cleaning, or for inspection, like identification, what's the condition of pipeline. So this is the small process. This is launcher. The peaks are peak is in like a tool which is from pig launcher, inserted to a pig launcher and sent to pig receiver. It's just like bypass system which is cleaning internals of pipeline. And you can see here, just while cleaning process, it moves all internal wax, in most cases wax that to pig receiver. It's just for cleaning processes. So when we're saying pig, it's not just one format. A pig, it's like you can see here these four as an example. I put photos for pigs are like just for maintenance cases, just what inserting inside the pipeline just to clean the internals. So maintenance utility, it's called like maintenance utility pigs. Maintenance utility pigs performs gauging of the internal bore, cleaning and debris removal, batch separation of products, and sweeping of liquid from the line. Peaks can be unidirectional or bidirectional. You can see here example of a bidirectional peak. So another one is foam peaks, molded from polyurethane. Foam is in various densities with various configurations of solid polyurethane strips and or abrasive materials permanently bonded to the surface. So another one is mandrel. You can see here like photo. Mandrel is central metal body with various components like cups, discs, wire, brushes, scraper blades, gouging plates attached, and see here how it's like configured. So this was a model, and utility peaks can be run as a dual module to facilitate negotiation of tight bands or wire configurations. The coupling can be subject to high transient and fatigue loads. Especially peaks can be used for wax detection, as I mentioned, removing hard scale with a pinwheel, magnetic cleaning, internal coating, leak detection, and other functions. Like we can just by sending pig inside the pipeline, we can do cleaning, repair, integrity measurement, to carry out integrity measurement, all just without like opening equipment for and taking offline equipment for big time just for inspection and repair. So there is different types of peaks, it's gel peak. So a sphere you can see here as an example. This type of peak, like sphere, are normally used to sweep liquids from gas lines. Sphere peaks are normally either made from the foam throughout or consist of elastomer skin inflated with glycol and water. Soluble spheres are sometimes used in crude pipelines and are made from a microcrystalline wax and amorphous polyethylene that acts as a paraffin inhibitor. Soluble spheres are broken up by the crude oil and do not require a receiver trap. So this for like just cleaning, repair, and just like moving inside like a wax removal process, like targeted peak types. And the rest you can see here, we call it as intelligent peak. This is not just moving inside, it's inspecting inside. Like there are sensors, ultrasonic sensors, which while moving inside the piping, just taking measurements and providing us the condition of pipeline, and if there is any wall loss, like metal loss with internal or external, it's giving us signals, and we can predict, we can exactly find where there is metal loss in the pipeline. And first one is magnetic flux intelligent. Regarding magnetic flux equipment like inspection tool, you will know more during our next session regarding pressure systems inspection techniques. And ultrasonic intelligence tool, you can see here, it's like both are for internal inspection of pipeline, but this is like for different, like with different tolerance, with different aims. We cannot say that this is much more better or like worse. Magnetic flux have its own limitations, and UT similar to this, like they have limitations. So regarding pipeline integrity management, this is all, and another topic, like another systems what we are going to cover during our session is civil structural integrity management. At the beginning, you have seen in our agenda that civil integrity management system and structural integrity management system. But now, like from process point of view, within BPA, we combine them together, and we call just civil structural integrity management. The objective of civil structure integrity management is to ensure that integrity of all civil structural systems and equipment are under proper control. So during our like starting from like during today's session, when we talked about facility integrity management, mostly it was like pressurized systems, like protection of pressurized systems. In pipeline as well, we have internal pressure, but civil structural is mostly covers like buildings, civil infrastructure, office buildings, local equipment rooms, storage tanks, bunds, pipe rack, structural steelwork, roads, handrails, grating and stairs, communication and enclosed circuit television towers and light poles, major steel and concrete structures, buried sewer and drain systems, closed drain and open drain pits, settlement monitoring of foundation bases for major facilities, tanks, pick traps, and slab catchers. You can think that if handrail is damaged, what is the impact for the integrity from like engineering point of view or from a safety point of view? But sometimes like we cannot use like stairs without holding handrails, and if handrail damaged, it means that we cannot use the stairs, and we cannot go to our pressurized equipment or to our dedicated location within like no integrity provided system. And even painting or road, imagine trucks are moving inside the like terminal in most cases, and road is like there is subsidence on the road, and vehicles cannot move on this road, and everything related to let's say like it's just called civil and structural, like any structural equipment under this integrity management system. So this is like that was equipment covered under this management system, and here you can see protective systems. Like protective systems are safety critical design measures designed to provide primary containment, protect and allow personnel working on process facilities to escape in case of accidental fire and explosion, protect against flooding, security threats, and generally protect the environment. Examples are below, like firewalls, blast resistant walls, and building with key equipment and control facilities, pacifier protection. This is also like this is a protective system for equipment, but protective system is inspected, monitored by civil structural integrity management part, pipe racks and buildings, structures, foundations, supporting equipment shutdowns, valves, containment bands around storage tanks, dikes and drainage facilities to prevent flooding, fire water systems like exactly in our case, but buried ring mains, monitors, storage ponds, tanks, and associated drainage, fire seals, traps, and vents in oil water systems, security walls, barriers, fencing, and protection screens, inspection strategies shall ensure that the condition of the civil structural components associated with the protective systems are checked regularly to ensure there is no significant degradation in their capability. And as an example, I will show how it look like when we say that, for example, if anything happened here in this facility, like this is Sangachal terminal, just what unexpected case happened here. At the beginning, we have all systems, like starting from facility integrity management to like accepting a pipeline to civil structural integrity management like team. All of them are coming together to identify what's happened. And if it's related to equipment, you can see here, it's in this case, it's piping. So this is related to facility integrity management system. But if anything happened in ladder, ladder or support on which equipment is sitting, and if, for example, there is crack or damage, from time to time, this equipment integrity will also fallen, and it will lead to catastrophic cases. And in this case, for example, when you see this picture, what's required to civil structural boundary is like pipe racks, pipe equipment support structures, piping cable trays, and any equipment supported on a pipe rack or support structure should be inspected as part of the piping, electrical, and mechanical inspection programs by the relevant disciplines. However, all structural steelwork, ladders, cages, fireproofing, structural bolts connecting the equipment saddle into the steel structure, base plates, and foundation pedestal should be included in the civil structure inspection scope. So if anything is happening, all teams have their own responsibility to measure, to calculate, and to provide on-time response to regarding his own we call it equipment ownership. So when you see here, all equipment have its owner within the company, and if anything is happening, we have people to direct our request to them. So structural civil structure integrity management, for example, this is structural beam, and like this is just elevation part within the facility. So when we look at it, it's a little bit difficult that who doing what in from integrity point of view, but we have clear identification that here structural beam we have for all facility for all structures, as I showed before previously. We have clear definition of what need to be done by which discipline. So civil structural team is monitoring integrity responsibility is under SCIM for this part, runway beams and lifting equipment. Runway beams and lifting beams should be inspected and tested as part of lifting equipment program. However, the structural inspection work scope should include the structural connections between the runway, lifting beam, and support structure or building frame. So you can see in the picture there is subsidences went on due to poor project project designing, or during high load affected in this place. So you see here, all civil structural is meant that any subsidence happened here. It's not just like a native case. It's not just earthquake. It's just subsidence. The ground is very reliable, very applicable for subsidence. Ground is subsiding. And when we say, like in this case, it's Sangachal terminal, collapsed soils are affected by external water ingress. This can lead to foundation settlement, meaning that the condition of process and area paving and aprons, particularly joints and the associated surface water drainage systems, must be closely inspected by the civil structural team. Other inspection teams need to inspect the drainage and containment systems in these paved areas to ensure that any water from above ground wash down facilities and leaks from plant and piping are adequately drained or contained. So again, similar case here. For example, if it's water accumulation process, civil structures like integrity responsibility is to solve this problem like subsidence issue, but water accumulation process is need to be done by other like facility integrity management system. In this case, like maybe pressurized system or mechanical. So this is like how boundary is working like for civil structural integrity. So this is you can see overall like a schematic picture of Sangachal terminal. Like you can see the road, as I mentioned at the beginning, for civil structure integrity management, so that on the road anything happened is under civil structural integrity management responsibility. Access roads and drainage outfalls, the inspection of access roads, drainage outfalls, both inside and outside facilities shall be performed by civil structural team. So this is by like doing by understanding this process, like similar for offshore as well, like handrails, ladders, and stairs. If there is any issue is happening or any request need to be done or any damage degradation happened on site, we have own like each own integrity management systems, and we know to whom to address, when to address, and who can be, how to say, our accountable person for this. And this is all what like I wanted to talk to you regarding integrity management systems. Like it's just awareness session that how we manage our integrity, how we control, and who is controlling integrity within our facilities. And this is this is just overall, and for next sessions there will be corrosion management, corrosion and process pressure systems will be deeply introduced to you. For example, I am talking about inspection, just like, for example, stairs corrosion, but in our next sessions, you will clearly understand why is corrosion is carrying out, and what is the inspection, what's the control methods need to be carried out under integrity management. That's all from my side. If any questions you have, can address.
Thank you for your great presentation, Aynura Hanım. We actually have one question in chat. Rasul Amirov asks, is intelligent pig a robot?
Yes, we can call it as a robot, because intelligent pig, it's just like a tool which have its own program, knows what to do, and while it's moving inside the pipeline, we can like monitor from the like from the our computer. We can see here how it's moving, where it's located. We can call it robot, but it's not as smart as new technologies applied. You will see what the robots do we have. We don't say is as a robot. We call just smart or intelligent tool, but if we are seeing what is this tool is doing, we can call it as a robot, because it's just programmed tool doing what we want inside the pipeline, measures anything we want, and showing where it's located.
Okay. We don't have any other question, but if someone has a question, you can unmute and ask it. It seems there is no question. Then thanks again, Aynura Hanım, for your presentation.
Thank you.
And we'll see you on Wednesday.
Yes.
Again.
Yes.
Yeah.
Have a good day. Thank you for listening.
Have a good day and bye.